SARASWATI 2.0 Podcast Talks.
Hello, we are here with the podcast 3, where we'll be talking on challenges and solutions in implementing SARASWATI 2.0 technologies. The very first question comes in terms of challenges. What are the challenges at the technical and operational fronts that project faced during its implementation?
Some fine-tuning is required to suit the technology for the Indian condition, because the weather conditions, the ambient conditions in Europe and in India, they are different. For example, when we tested, say, purple non-sulfur bacteria, which the technology which is developed by our European partner TU Delft under laboratory condition. So when the technology shifted from the bench scale to the field scale, we face several challenges: unwanted growth of microorganisms. Then insects were coming to eat those bacteria which we are culturing, because the protein-enriched microorganism, maybe the unwanted insects were liking it too much, which is not the case in case of European countries, because you don't get that level of flies and other insects.
Yes, it was also quite challenging to get monitoring and sampling programs parallel for all those pilots. We did a monitoring plan with all the details, and what should be gathered, but the pilots were so different. So we wanted to have as general as possible, but it was quite a big challenge to get them parallel. But however, I finally find that with all those publications and all this effort from the Indian partners, especially, the data which was gathered was sufficient enough to demonstrate the energy and the environmental aspects and also investment aspects sufficiently in order to make decisions for choices of technologies in the future.
So tell us how you manage this collaborative project, because it's international projects. You are having around 18 to 20 different heads from different countries, and how you made this international team to work in a so nice and synergized way.
As such, because as I said, we were working with most of our partners, European partners earlier, so we had some basis of understanding each other. So for exchanging thoughts, exchanging the ideas, exchanging the technologies, we didn't face any challenge. We are lucky enough and fortunate enough to have better understanding with our partners, collaborating partners, because unless we disclose the details of the technology, complete implementation may not come up to the required expectation.
I think one of the keys to the success of this project is people that worked on it. Dr. Phillip and her group at IIT, she had some very industrious and serious students. On our end, we were 3 senior researchers: Professor Zaid Ronain, who was the environmental microbiologist, Professor Yoram Oren, who was a electrochemical technologist, myself, and we also had a very skilled and talented postdoc working with us, a guy by the name of Akshaya Verma, who actually also happens to be from India. I think that was a key. And I think that's something that's really, really important not to forget, is that for these things to work, you have to have the right people working on it. And we were fortunate in that respect.
Major background is, I suppose, that we were working among the engineers. From the EU side, there were specialist technologies engineers, and also those Indian partners were institutes of technology. So those people, we all were working for the same goal, and we were talking the same language, so we could understand technically and technologically the nuances of the technologies, and I suppose that did help a lot throughout the project.
How do you find the energy efficiency in this project?
Energy efficiency, definitely, while selecting a technology, we evaluated with the preliminary evaluation that the technology that we are implementing should demand less energy. That was the first screening criteria that we had. Having said so, we do implemented thermal hydrolysis of the sludge, which is energy intensive, but at the same time, it provides much more advantage downstream to meet the Class A criteria for the sludge disposal. So energy definitely has an important role to play while accepting the technology, because India, though we are progressing a lot with the augmentation with the non-renewable energy resources, but still majorly we are relying on the fossil fuel for the energy source. And reliability of the energy, many of the rural area, particularly when we are looking for a decentralized way of managing the wastewater. So energy assurance is, and then the less energy requirement is the primary criteria. But some of the technology we do have implemented, which demands energy, but at the same time, it provides distinct engineering advantages of implementing those technologies for complete managing the achieving the circular economy aspect of the wastewater management. So this aspect we kept at the forefront while choosing the technology for implementation.
So here in this affordable advanced wastewater treatment plant, okay, we can augment some electricity by the solar panel. That's easy. Anybody can do. Solar panel, we can save some of the cost.
And the other thing that would be done is at the bottom of the bioreactor, we would inject a low-cost carbon source. In our case, we used glycerin, because glycerin is often a byproduct of biodiesel, so it's relatively cheap, and it does not cross the membrane. Okay, you have to have a carbon source that doesn't cross the membrane, or else you contaminate your feed.
The availability of sustainable resources like biogas generated from wastewater treatment has also provided communities with a reliable and eco-friendly energy source. And the responsible management and reuse of wastewater have minimized the environmental degradation, turning potential pollutant into valuable, which further contributes to the sustainability practices. These combined effects have fostered stronger, more resilient communities with a reduced environmental footprint.
So having run this project for this many years, can you tell us about the implementation of this project on ground?
Particularly in this regard, IIT Kharagpur got opportunity to implement 3 technologies. One is electroconductive biofilter, another one is purple non-sulfur bacteria cultivation from the fermented sewage through the high rate anaerobic digester, and third technology is ultrasound treatment for the sludge. So local contractor as well as state pollution control board people visited our plant and appreciated the performance of the plant, as well as the central pollution control board people also came, and seeing the change in the water quality, even they were enthusiastic to collect sample themselves and analyze it in their accredited laboratory and certify to get the confidence that these technologies are working on the field.
The pilot has very efficient in organic and nutrient removal. The pilot plant provided a source of treated wastewater for non-edible crop irrigation in the campus, which is helping in forest belt development. Additionally, the methane generated from the biogas from the USB reactor, it has been used for cooking purpose. The efficient operation of the plant with its minimal sludge production, it has further reduced the environmental impact.
Similar experience we had where the European Union people also visited our partner at IIT Roorkee, and the SBR that indigenously they developed, that is also giving very nice performance.
It's a batch activated sludge process. Here we require at least 2 tanks. In the first tank, the flow counts along with the flow, along with the influent. The aeration takes place. And during the aeration, we have a BOD removal as well as simultaneous nitrification, denitrification. The flux happens. In the second tank, there the settling and decantation takes place, and thereafter we switch. So therefore, in the first tank, settling and decantation, and then the flow is diverted to the first tank. Then second tank, first tank, the 2 tanks, and we can remove everything together in these 2 tanks. Yeah, this is the main activated sludge, normal conventional, but in the batch mode.
Then rotating biological contactor, the technology which is implemented by our partner IIM Mumbai, that was also visited by many of our European partner and European agency personals, and they are also happy about the performance of the plant. So overall, we and similarly IIT Madras, the ion exchange membrane, So that is also visited, and the plant is giving good performance. And now it is implemented in actual field conditions. So rather than testing it within the academia, so now it is being tested at the sewage treatment plant located outside the IIT Madras campus.
They added an ultrafiltration module, which would scavenge any bioflux or any suspended biomaterial that might escape the fixed bed bioreactor. They really did translate it into a system that could be applied and used in a industrial setting. So this was really a case where each of the two groups provided a valuable and essential contribution to making the overall project succeed.
So, as you rightly said about the implementation of these projects on ground. So, and of course, there are stakeholders who are like end users of these technologies as well as the site where it has been installed. What do you think what was the reaction of the local communities and what was the acceptance rate? Let me tell more directly, like what was the feedback of all these local communities which were directly as well as indirectly involved in this project?
Along with the technical implementation, we also conducted a stakeholder workshop at the location of all the partners, involving the municipality, involving the state pollution control board people, or many of the states, they have public health engineering departments. So those engineers and personnel were involved in the stakeholder workshop to get a feedback about the implementation of the technology and socio-economic evaluation that we carried out, including life cycle assessment of these technologies. And some of these technologies are having really positive feedback from all the stakeholders involved. And some of them, as I said, they are still at the technology readiness level of 7. So require some modification for rigid implementation for implementation elsewhere, so that the reliable performance of the system can be obtained. So some small fine-tuning is required to get this technology adapted to Indian condition in particular, or in application to make them ready for application in the developing countries in general. But we are in the directions, and almost the 10 technologies that we implemented, most of them are successful and having positive feedback. Say, for example, the IIM implemented the rotating biological contactor. The Bombay Municipal Corporation has adopted that plant, and now they are shifting it from the experimentation space to their demonstration plant. So the plant is only 100 cubic meter, but they would like to continue themselves maintaining that plant to demonstrate that at the small scale also, the RBC with other annexures, it works. So that level of positive feedback we have from the agencies.
What I think is very important here is that, of course, one target is to improve the environment, but at the same time, the whole aim of the larger program, the research program, was basically to also look into reuse opportunities for, let's say, what initially was wastewater after treatment becomes basically a new resource as water for other type of purposes. So obviously the environmental impact is one of them, but secondary is what impact could the clean water have once, let's say, it becomes a new resource. And that part, I think, is quite interesting there. In total, in the SARASWATI program, there were 2.0, there were quite a lot of pilot studies. They all focused at a different type of reuse. So could be reuse for agriculture, could be reuse for golf courts, could be reuse ultimately for hospital water. So there were different purposes. Now, obviously, they all generate a different impact for the different communities involved.
Thank you, experts, for sharing your views on the challenges and solutions in implementation of SARASWATI 2.0. And thank you, audience. I'm very hopeful that you must be getting a lot of insights and not only the general knowledge, but even specialized knowledge after watching these podcasts. And our next podcast is planned for the success stories and future prospects. Stay tuned. Thank you so much.